Alright, today we're going to talk about what was one of my most favorite math subjects when I was a student in school. We're going to talk about lines of symmetry, okay? And pretty much, symmetry means that an object or figure is made up of exactly congruent parts. So as mathematicians, what we do with objects is we may try to identify lines of symmetry. A line that we can draw into a shape that will separate the shape in two equal congruent parts. Now, a little bit of a disclaimer here. I have tried to draw these shapes the best I can to be regular and similar where we talk about lines and symmetry. So if they're off a little bit, give me a little bit of wiggle room. Okay? The practice problems that you may see online or practice problems that you may see in your math book, those will be more equitably drawn and they will be more congruent than my hand-drawn figures on a whiteboard. Now, the first time I remember really thinking about lines of symmetry is when I was like a kindergartner or first grade. It was Valentine's Day. I was making Valentines for the rest of my students, or the rest of my peers in my classroom. How many of you guys can relate? Our teacher taught us to take the red sheet of construction paper and fold it in half, and then go ahead and cut the fish hook into it to make a heart. And then when we opened it up, we had two halves that were exactly the same. From there through the years, we started folding paper and cutting different things out to make snowflakes. During the winter holiday season, all of those require lines of symmetry. And if I look at my heart has one line of symmetry. A line that I can draw through the shape, if I could draw a straight line today, guys, that is going to split it into two equal halves. Now, a heart is a shape, it is not a polygon, similar to a circle. Circles are pretty regular geometric shape that you'll study through school, but it is not a polygon because it doesn't have straight sides. But a circle we can split it into two equal halves with a line of symmetry that way. We could do it this way. We could do it this way like a pizza. This way like a pizza. Who says you won't use math in a later career? That first job at Pizza Hut, you may be rocking lines of symmetry. Matter of fact, circles can have infinitely many lines of symmetry all the way around the degree marks. Okay? Now let's look at some common geometric figures we have. We have a square. Remember, a square is identified by having characteristics of a rhombus and a rectangle. It has 90-degree angles and 4 congruent sides. I can draw a line of symmetry straight down the middle. That's like folding it in half. I could actually fold it vertically and bring the bottom up to the top. Because it has equal sides and equal angles, I could fold it diagonal and make two right triangles that are of the same shape and size. I could also fold it along this diagonal and take this triangle and that right triangle as well. Some of you may now see 4 triangles in there, or you might have seen 4 smaller squares. For lines of symmetry, we're not concerned about that. We're only looking at how we can split the shape into mirror images of itself, 2 exact parts. So, my question to you is, if we can do all that with squares, do rectangles with their 90-degree angle measures have the exact same number of lines of symmetry? Draw a rectangle on your paper, pause the video, take a few minutes to see if you can get 1, 2, 3, 4 lines of symmetry in a rectangle like you can with a square. This is me being paused. Anyway, back on point. If you did this, pause the video and looked at a rectangle, you should have seen we could really easily get a line of symmetry there where we'd fold our rectangle in half. You could fold your rectangle in half top to bottom that way. But if we draw a diagonal from this corner to that corner, again, if Mr. Dave can draw straight, this corner won't line up perfectly with this corner. Matter of fact, I'm going to step off camera. to help illustrate this, I got a sheet of paper that is a rectangle. If I fold my rectangle along a diagonal along from corner to corner, and I'm folding about as well as I draw today, I end up with a shape that's slightly off-cantered like this. That's not a line of symmetry. It's only a line of symmetry if it folds up perfectly. Rectangles only have 2 lines of symmetry when a square has 4. Let's look to triangles. Here I have what looks to be an isosceles triangle, 2 same sides, similar side down there. I can go ahead and split that straight down the middle, and I end up with 2 right triangles that match each other. Well, can I take a right triangle and put a line of symmetry in it? Unless it's a right isosceles triangle, meaning that this side and this side were the same, we wouldn't be able to do that. And it's going to vary from right triangle to right triangle. My right triangle does not have 2 similar sides. If I was to fold it right down the middle, this side would end up short of that side. And it would look something like this. That's not congruent. Now, if I had an isosceles right triangle, that was one of those wider, fat bottom triangles, we would be able to draw a line of symmetry into that. Here I got an obtuse triangle. This triangle is kind of the same way. I can't split it this way because that wouldn't give me 2 foldable halves that match perfectly. I can't really do it this way. It won't give me 2 foldable halves that match perfectly. Only isosceles triangles could we draw a line of symmetry in that will have 2 obtuse angles. One obtuse angle. So there are none in this particular triangle I drew. There's none in this right triangle that I drew. But that doesn't mean you won't find a right triangle with a line of symmetry or an obtuse triangle with a line of symmetry. Let's look at a rhombus. Remember, where a rectangle is measured by its angle measures, a rhombus is measured by its side measures. So if it's measured by having the 4 same length of sides, do you think it'll have as many lines of symmetry as a square? I could take my rhombus and fold it along this line. Now I have 2 triangles. Matter of fact, I have 2 isosceles triangles. And this is an obtuse angle. This would be the type of triangle right here that I could fold again. I could draw in a line of symmetry right here. I could fold it top to bottom. But unless these angles are 90-degree angles, I'm going to run into a similar issue as I did with the rectangle. I can't fold it down this line because these angles might end up counter to each other. Unless, of course, that rhombus is a special rhombus, which is a square. I got 2 more shapes. I got this shape right here. It's a random shape that I can draw a line into. That will fold it and make it perfectly. So the last thing I'd like you to do is a challenge. I'd like you to look at the shape in the box. I'd like you to figure out if you think this one has any lines of symmetry. Maybe post a comment below. Have a great day. We'll see you next time.